For today's lesson, we will do some review for our unit tests on special functions. On the review packet here, I'm going to pick a few problems to do together, and then the assignment will be for you to finish the packet for tomorrow. So we're going to start with number 1. We're going to recognize that in number 1 we have that absolute value function. We have 3, the absolute value of x is minus 4. And we know that when we sketch our absolute value functions, that those graphs have a V shape. To get us going on our sketch, we will first recognize that the 3 out in front of our absolute value is going to scale up our parent graph by stretching it vertically. It's going to change the slope of our two sides of our V to have a rise of 3 and a run of 1. We also have a minus 4 on the end, and we know that anytime something is subtracted on the outside of the absolute value bars, that means that our graph is being translated down 4 units. So we'll go and start by making that sketch down 4. And from there, we will use our slope of 3 over 1. We also know that this curve is opening up because that factor of 3 is positive. So from our point here at 0, negative 4, we're going to go up 3 and over to the right 1, and up 3 and over to the left 1. At that point, I am able to sketch my graph. And now we can go on to answer our questions. We know that our vertex lies on that y-axis at the coordinates of 0, negative 4. We already decided that our curve opens up, and now we will talk about the domain and the range. For the absolute value functions, the domain will always be the set of all reals. And our range values, in this particular case, since we did shift our V shape down 4, our y values are starting at that value of negative 4, and they are going above. So we would say that we want all of the y's bigger than or equal to negative 4. We're now going to move on to our second page, and we're going to look at problem number 5A. Shifting to page 2 brings us to piecewise functions. To get us going on the graph of our piecewise, we know that we're going to look again for those endpoints. Since our inequalities here are talking about what's happening around that value of 0, those are going to be where our endpoints exist. So we will start off by figuring out what those corresponding y values are for each of our endpoints. When I plug in the 0 into this top function, I'm going to get negative 0 plus 2, which gives me the y value of 2. I also know that when I look at my inequality here and I see that I have a less than or equal to for that value of 0, since it's equaling that value, then I know that I'm going to include that point on my graph. So I'm going to graph that point at 0, 2 with a closed dot, which would again indicate that that point is included in my function. Let's go down and do the same thing for our second function. We know here when I plug in the value of x as 0 into the 3x minus 2, the 3 times the 0 is going to be 0, and then minus 2 would give me a negative 2. For that point, since my inequality here is a greater than, it's not including that point, we don't have an equal to sign, then I know that when I graph that, I'm not including the point, I'm just getting close to that, and I would represent that by an open dot. At that point, the only other thing we need is to figure out what the slope is for each of these linear piece functions. So we will go here first on our top one, remembering that the slope is that number in front of the x value. So in this setting here, it would be this one. Our slope here is -1/1. And for my second function, the number in front of x is the 3. And my slope for that one then, if I wrote it as a rise over run, would be the 3/1. So now I'm ready to start my sketch. I'm going to do that first piecewise function in red. We're going to go to that point at 0, 2, so 0 left and right and up 2, and I am going to include that as a solid dot. Since I know that my inequality is for only that piece of line for x's less than or equal to 0, then I know that I'm graphing this line piece on the left side of this point. When I do the motion of -1/1, and I want to have that ray only on the left side, I'm going to go up 1 and left 1, up 1 and left 1. And I'm going to connect those points to make my ray. To graph my second piece of this piecewise function, we know we're going to start here at the point 0, -2. So I'm going to go down to -2, and I'm going to use a nice open dot there to represent that point. These values are going to be sketched for only the x's bigger than 0. So I'm going to use my slope, which is that 3/1, from this point at 0, -2. So I here would rise 3 and then run 1, and then rise 3 and run 1. And when I connect these points, I would get the second piece of my piecewise function. At this point, we're able to go through and determine that this graph does represent a function because it does pass the vertical line test. And also I'm able to go through and evaluate my function. If I'm asked to go through and find what f of 2 is, I know that I'm looking for the piece of the function that is defined for the value of x equal 2. Since the bottom portion of my function is the one for x is bigger than 0, and since 2 is bigger than 0, I will evaluate that piece at 2. I get a 6 and a -2, and my answer should be 4. I always like to go and check to make sure that that corresponds to a point on my graph. So if I were to go over 2 and up 4, I can see right there that that does correspond to what I evaluated. Going on to the next one, we're going to now let x be -5. Here we want x to be a negative value, which means our top piece is what we would evaluate. So we're going to put in a -5 for x and then simplify it. Here I get a 5, adding a 2, we should get a 7. And again, going back to my graph, if I were to go back 5 and go up, I can see that that point right there is my -5, 7. And the last one is when x is equal to 1. This one here, we would again go back to use the bottom function, plugging in the 1 for x, and then simplifying, we end up getting a 3 minus 2, which would give us a 1. And once again, looking back at my graph, going over 1 and up 1, I again can circle that point at 1, 1. The last problem that I'm going to go through is our square root function. So now we are on the third page. The third page talks about that square root function. All they want us to do in this first problem here is to go through and describe the domain and the range. So I'm going to go through and do part A with you, and I'll leave the rest for you to finish. When we are looking at domain, we know that domain represents all of the x values. When I look at my graph here, I'm going to look at all of the x values that that graph touches. I can see here in red that the first x value that's touched is the 1. And then it goes on to include all of the values to the right of that. To describe the domain using an inequality, we will say that we want all of the x's bigger than or equal to that value of 1. To go on to describe what happens with the range values are all of your y values. When I look at my graph here in 6a, I can see that my graph for my y values is starting right here. And it's continuing to also get bigger. So for my range values, I would say all of the y's bigger than or equal to 2. So I will let you complete the packet, and we can discuss any questions tomorrow, and good luck. Thank you.